Today we're looking at lesson 6.4, Leapfrog. Our objective today is I can list one or more rigid transformations that carry a figure to its image in 2 out of 2 problems. So up to this point in this unit, we've talked about taking an object, applying a transformation, seeing where it ends up. We're kind of going to do that in a different order today. We're going to look at an object and look at its image and see if we can figure out which transformation or multiple transformations took it to that image. So to start off with, let's talk about the concept of an orientation of vertices in a shape. So you can see we have a pentagon here. If we start at the vertex, and a vertex means a corner, a pentagon is a 5-sided polygon. So we start at this vertex J, and we're going to go clockwise. This is arbitrary. You can choose to go whichever direction you want. You can go clockwise or counterclockwise. It doesn't matter. But you can see if we go clockwise on this one, it'll go J, K, L, M, N, and then we'll be back to J, and we can do that forever in a circle. J, K, L, M, N. And that goes in alphabetical order. We tend to name polygons this way with alphabetically ordered vertices, because it makes sense to our brain. But when we transform a shape, it has the potential to change the order of these vertices. So the question we're asking here is, which of these transformations changed the order of the vertices? Does a translation, a reflection, or a rotation, or maybe multiple of them, change the order? So if we start at J in each one, start at J and go clockwise, then we'll start at the image of J and go clockwise and see if we get the same order. So here we have J, K, L, M, N. When we go clockwise, J, K, L, M, N. When we start at J prime and go clockwise, we get J prime, K prime, L prime, M prime, N prime. J, K, L, M, N. You can see the original object and the image go in the same order. They go in that alphabetical order, J, K, L, M, N. So translation did not change the orientation. Now let's look at a reflection. You can see this is reflected, this shape is reflected over a vertical line right between them. The distance here is the same. Remember we said perpendicular distance. Now if we start at J, we know this is the original object because it doesn't have the primes. This is the reflection. If we start at J here and go around clockwise, we're going to get J, K, L, M, N. Again, that makes sense because we just used that same shape from before, J, K, L, M, N. Now if we start with the J prime and go clockwise, we get J primed, N primed, M primed, L prime, K prime, back to J. So this went J prime, N prime, M prime, L prime, K prime. You can see this order now, JN and JK, this has changed the orientation of the vertices. It actually reversed it, right? If we bring this J prime over here, we pretend it's not there. Now this is going backwards alphabetically, N, M, L, K, J. That's backwards. So this reversed the order. Notice the sequence is still the same, right? The ones that they're adjacent to are still the same. K is between L and J. K is still between L and J in both of these. It's just the order when we go a particular direction has changed. So we've reversed the clockwise order of the vertices. That's what we mean by the orientation of the vertices. So reflection is a case where the orientation of the vertices changes. Well, let's look at our last one here, rotation. We're going to do the same thing. We'll start at J, go clockwise. We get J, K, L, M, N, just like normal. J, K, L, M, N. And now we start at J prime and go clockwise. We have J prime, K prime, L prime, M prime, N prime. You can see we've rotated this shape about 90 degrees clockwise, and we still get that same order. J prime, K prime, L prime, N prime. It still goes in alphabetical order. So for rotation, we also got no change. So notice of these three rigid transformations, the only one that changes the orientation of the vertices is a reflection. That means we can use the orientation of the vertices to sort of predict what transformations happened, whether or not one of them was a reflection. If it did not change the orientation of the vertices, if it didn't change the order of them, then we will not see a reflection. Similarly, if we do see a change in the orientation, if they changed the order of the vertices, then we expect there is a reflection going on there. All right, so let's get to our application of this today. We're going to look at leapfrog animations. And Josh is animating a scene in which a troop of frogs is auditioning for the Animal Channel reality show, The Bayou's Got Talent. And in this scene, the frogs are demonstrating their leapfrog acrobatics act. And he has drawn an initial frog, and now he needs to use rigid transformations to make its acrobatic images. So he's laid out this storyboard here. You can see it's on a coordinate plane, so we can see all the places specifically it needs to move to. What kinds of transformations can you see here between image 1 and all the subsequent images? Maybe you can see some translations moving up and down, left and right. Maybe you can see rotations, cases where maybe the frog is facing a different direction, so those might be either rotations or reflections. We have to figure out which one. So I think maybe we see all three of our rigid transformations here. But Josh is using a computer program, which means he has to be very specific with his instructions. Computers aren't very good at interpreting statements and figuring out like, oh, just a little bit up and a little bit to the right, maybe a little bit more to the right. Computers aren't very good at that. They need very specific instructions to know where to go. So when we instruct it to do these transformations, we're going to have to provide very specific information. When we do reflections, we will have to specify the equation of the line of reflection. When we do a translation, we'll have to specify how much change in x we have and how much change in y. And for rotations, we will need the center of rotation, the direction of rotation, and the measure of the angle. We need 3 things for rotations. So let's take a look at these. Remember that you may need more than one transformation. You may need to do 2 in a row or even more. That is an option for these. And I have a link for you to try this out. We have a little Google Slides where you can move the frog around. And I'm going to show you how to use that, how to do some rotations and some reflections on that. So here are the Google Slides where you can manipulate the frog, and I'll put this link in the YouTube video. Notice the one that says move me, you can pick it up, move it around, move it on top of the images, and then we can try to manipulate it to get it to be the other images. So if we want to move it up and down, obviously we just pick it up and move it up, down, left, right. If we want to rotate it, we can use this little circle on the top, and that will allow us to rotate it to whatever degrees. Notice it shows you what degrees we're at. If you hold down the Shift key while you're doing that, it'll restrict it to only measures of 15. Now remember, we're actually restricting to 90, 180, and 270 in this unit. So that Shift key is super helpful to get those very specific rotations in, 90, 180, and 270. Reflections are a little bit trickier. What you're going to need to do is grab one of these sides grab the little box there, and drag it to the other side. And you'll see when it becomes a perfect square, or the perfect reflection image, you'll get that red diagonal. So that'll give you a reflection across a vertical line. Or if you want to do a reflection across a horizontal line, you'll do that with the top box down to the red diagonal again. You get a reflection. Notice that reflection is going to be over the line that's right on the tip of his toe there. So it's not very good at doing reflections over other lines, but we can sort of imagine how that would happen. All right, so I'm going to take him back to the beginning. And our first one we're going to do is image 1 to image 2. We're going to try to figure out which transformation we're going to use. And we have to be specific with it, so we have to provide the details that we need. So take a look at this, maybe pause the video, try to figure out how we'd move image 1 to image 2. You can use the Google Slides to help you out. Okay, so here we have image 1, and we're going to change it to image 2. Now, it looks like the orientation is completely the same, the direction he's facing is the same, so maybe we only need to move this up and to the right. Maybe not quite up that much. There we go, up and to the right, and that pretty much matches. So we figured out the transformation is up and to the right. We just have to figure out how much up and to the right. Maybe we can zoom in a little bit here so we can see this better. How can we figure out how much this moved up and to the right? Do you have any ideas? Well, maybe if we look at the original image, say like the middle finger on his left hand, which would be on our right side. That is the original object to this image right here. Same hand, same finger, and if we draw a line there, maybe I'll make it bright blue and a little bit bigger so we can see that line. That shows us the change. It showed us the change from this point to this point. And because we know it's a translation, all of these changes should be the same, right? They should be parallel and the same length. So we just have to figure out the change in one of them to know the change in all of them. So let's see. From here, we went right 1, 2, 3, 4, 5, 6. And we went up 1, 2, 3, 4, 5, 6, 7. Or another way we can think about that is we could look at the actual coordinates that we changed. So I need to zoom back out here so I can see the whole thing. But our original coordinate here for his little middle finger were, that looks like 7 on the X and 22 on the Y. So let me just grab my text tool here. And we say that original one is 7, 22. We'll write it as a coordinate pair. And then the new point up here where we went to, that looks like 13 and 29. We'll type that up here, 13, 29. And then we can ask, what is the change in X? What's the difference between 13 and 7? Well, that's just 13 minus 7, right? That's what we mean by difference. 13 minus 7 is 6. 29 minus 22 is 7. So that describes our transformation. It is a translation. We went up and to the right. And we said we went up. Well, we went right first, right? We went right 6 and up 7. And we can just describe it that way. That's enough. We did have this more formal syntax that we have used, that you are welcome to use, where we say x and y go to x plus 6, right? That's the same thing as right 6. And y plus 7. That's the same thing as up 7. So either of those descriptions would be just fine, just as long as we specify it is a translation. All right, let's try another one. We're going to do image 2 to image 3 now. Go ahead and pause the video, see if you can come up with a transformation or two that would perform this translation. So our next one is image 2 to image 3. So we already got image 1 moved to image 2. We're going to start here with image 2 and try to figure out how to move it to image 3. What transformation or multiple transformations can you see there that would take this frog to that frog? Pause the video, see if you can play around with the manipulative on the Google slide. Try to get this frog turned into this frog, and try to remember what you do with it to get it there. Okay, so I'm going to go back to my Google slide. And I'm just going to go to the next slide. Notice we have multiple, so you can start over with a frog that hasn't been moved yet. And if you need more slides, you can just right click here and do duplicate slide, and that will give you a new one. So we moved our frog up here to image 2, and now we're going to try to figure out how to get it to image 3. Let me zoom in here. So it looks like this frog is upside down. It's going to be more than a translation. It's going to be something else. There are a couple of ways we could get the frog upside down. Is this a rotation or a reflection, or maybe both? How do we get the frog to look like that, to be upside down like that, in the right orientation, facing the right way? Well, let's see what happens if we try a reflection. If I do a reflection this way, that doesn't really look right? That didn't make him go upside down. So we need the frog upside down. Let's try this way. Let's drag this box down here. And I need to get to that red diagonal. There we go. Now, the frog is upside down, but now it's facing the wrong direction. Right? That didn't seem to work either. So maybe instead of a reflection, let's try a rotation. Let's see if a rotation could get us there. So I'm going to hold down the Shift key again so we get exactly 15 degrees each time. I go 90 degrees, looks like they're on their side. If I go 180 degrees, oh, look at that. Now they look similar. So maybe this involves a 180 degree rotation. Now in Google Slides, when they do a rotation, it's always around the center of the object. We can actually do rotations around other points. You know, we've talked about doing rotations around the origin, points outside the object. But Google Slides isn't really a math program. It's not that smart. So it always does its rotation around the center of the object. So that was a 180 degree rotation. We went clockwise around the center of the frog. We could also go counterclockwise. So if we start up here, oh, let's get back to 0. There we go, start at 0. We could have gone 180 degrees counterclockwise, and we still end up at the same place. So 180 degrees is kind of this magical degree right in the middle of a full circle where you can go clockwise or counterclockwise and you get the same result. So from here, where would we need to go? Well, we basically need to translate it, right? We could take this middle finger here over to this middle finger there. So we could take, and in fact, let me use this arrow, because translations we've described as vectors, right? With the arrow. So it makes sense to display them this way. Let's make that blue. So what change is this vector describing? Well, it looks like we go up one, we go right a whole bunch. We go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 10, up 1. So we did this in 2 steps. We did a rotation around the center of the frog, and then we did a translation, 10 right and 1 up. Let's write that down. We started with a rotation. We went 180 degrees. It doesn't matter which direction, so we'll just say clockwise. And then we did a translation where we went 10 right and 1 up. Now we're actually missing a piece though, because we did the direction of the rotation, the measure of the angle, but we don't have the center yet. We still need to find the center of our rotation. And the best way to do this, we sort of estimate this whole object with a square. Let's see if I can make this a little bit more precise. A square. And this actually isn't a perfect square. This is actually a rectangle. And so we need to find the center of the rectangle to figure out where we're rotating around. And you may know, or you may have some ideas about how to find the center of a rectangle. Have you done this before? Do you know what you can do? We could get out a ruler and measure from one to the other. We could just count these squares, right? There's 1, 2, 3, 4, 5, 6. So 3 in would be the center. This is center line right there. And then we'd have 1, 2, 3, 4, 5, 6. Wait, did I lose count? 1, 2, 3, 4, 5, 6, 7. So 3.5 on this one. But even without doing that, we have another way we can do it, where we can take the diagonal of the square, and this program does not like drawing diagonals, and take the diagonal of this rectangle. I keep calling it a square, but I mean a rectangle. Take that diagonal, and where they cross, right there, where they cross right there is our center. So that looks like it's about the point 10 and maybe 27. That's going to be our center of rotation. Now just a quick tip on this one as well. Here's a zoomed in image of it. We can actually do this in one step. We just have to know something about 180-degree rotations, and that is that they are kind of special. And there's a special way you can figure out how to do this, how to figure out where their center of rotation is. So I'm back here in Google Slides. We're going to look at image 2 to image 3, knowing that this is 180, right? We already rotated it. We know that this could be 180. And we're asking, is there a place that we could rotate around that would make this a single transformation? Well, it turns out with 180-degree rotations, you can do this special method where I take the original object, let's say like the bottom of his lip here, and I draw a line to the image, just like that. And I'm going to do it again with a different point, maybe the eye above, like the middle of his eyeball, right above that edge of his lip. And I'm going to do it again, maybe his knee on that same side. What do you notice about these lines? Do you notice something happening? Let's do like the middle toe on that same side. Maybe we'll do the middle toe on the opposite foot. Do you notice anything about these lines? Yeah, they're all interacting, or they're all intersecting at the same point. That point for 180-degree rotations is the center of rotation. So if we zoom back out here so we can see our coordinates, we can see that point is right here at 1527, it looks like. So we could do this in a single rotation of 180 degrees around the point 15.7. So just a cool little tip there. So now we have another one, image 3 to image 4. Once again, we've already made it to image 3, so now we'll just need to take that to the next one, to image 4. Give that one a try, see if you can figure out the transformation that will take it there. See if we come up with the same one. So back here in Google Slide, we said we're going to do a 180-degree rotation, and we end up with image 3 right about there. We'll zoom back in so we can see. Now, what transformation will take us from image 3 to image 4? Well, it looks like it's facing the same way. If the frog is facing the same way, maybe we just need to rotate it another 90 degrees. Notice this says 270. That's because our original image was right side up. But if we start from here and go 90 more, we start from 180, go to 270, that means that's just a 90-degree rotation here. And that does put it in the right place. So I'll bring it back up here. We did a 90-degree rotation. Now it looks like we have that same translation we need to do. Not the exact same, but we have another translation. We have the same pattern of a rotation around the center of the frog, and then a translation. What directions did this translation go? So if we look at this middle finger here, down to here, it looks like we're going to go down. Let me draw my arrow. This middle finger to this middle finger. There's our arrow. So we just need to figure out how much that moved, how much that changed. So let's see, our down is 1, 2, 3, 4, 5, 6, 7, 8. So down 8, and then over 1 to the right, 1, 2, 3, 4, 5, 6, and maybe just a little bit over 6, maybe 6.3. So down 6.3, right, or down 8, right 6.3. So we said this was going to be a rotation and a translation. The translation we said was down 8, right 6.3. Remember, we also have this notation, xy goes to x. Now, be careful not to get these mixed up. Down is our y variable, right is our x variable, so this is right. We add 6.3. Down is a negative, right? We go down on the y, so this is y minus 8. So that's our translation rule. Our rotation, let's think back to what we did. We did 90 degrees clockwise. And then we'd have to figure out the center again, using that same method where we draw a square kind of around this frog. And we figure out where the center is by drawing diagonals. So you can draw a diagonal kind of like that. That's pretty close. And then draw another diagonal here. So we figure out where that center is. Looks like it's really close to about 2619. So we could do that in 2 steps with a rotation and then a translation. Now, just a tip, we're not going to go over this in the video, but there is a way to do this with a single step. And I'll leave that to you to figure out. It's a lot trickier because you'll notice if we draw these lines like we were drawing before, like his lip to his lip and his eyeball to his eyeball, you can see those aren't going to cross anymore. And this one crosses this way, and it just ends up being a big mess. So those intersecting lines only worked on 180. This was a 90-degree rotation, so it won't work. What we have to do is figure out some point out here that's the same distance from all of the original object in its image. So we'd have to compare like the distance from that finger to that finger, or from this toe to this toe. We have to determine if that's the same distance, right? That's how we figured out rotations. They were a radius away from a center. And they traced a circle. So another way we could do is we could draw big circles and try to find the center that they all shared in common. That might be maybe closer to over here. Who knows? Like I said, we're not going to go through it in this video. It's difficult and a lot of trial and error. So we're just going to move on because we found two transformations that would take the place of that single one. So this is our last one we're going to go over, image 1 to image 5. What transformations do you think could carry image 1 to image 5? Go ahead and pause the video, give a few a try, see if you can come up with some. Remember, you need to be specific. You need to tell us what the change is, what the center of rotation or the line of reflection. So try to figure that out. Come back and see if we get the same answer. So I'm back here in Google Slides, and I'm going to try to change image 1 all the way over to image 5. And maybe I think I'll try a rotation. Let's see if I can try to get a rotation to look like that. Well, that took the frog over on its side, on their side. Now they're upside down. Now they're sideways. I'm not sure a rotation is going to... That looks actually more like a reflection. Maybe we should try a reflection over a vertical line. See if we can get it to look kind of similar. There we go. Yeah, that looks right. So our original one, we started up here. Here, let's move them over. There we go. So we started up here. We did a reflection, and we got the right orientation here. We changed the order of the vertices. We changed the order when we go around the frog. And remember, Google Slides isn't very good entirely at math transformations. If we have a reflection, we can use a reflection line that's further away and get the reflection further away. Google Slides just doesn't know how to do that. So we need a line. So let's see, let's grab our line tool, draw a line somewhere in between them. Actually draw the line. Maybe make it visible. Okay, so what do you think about maybe this line? Or maybe a line more over here? Or this line? Does it matter which of these lines we use? Yeah, so the further away the line is from the frog, the further away it's going to land over here. So basically, we need to draw this line so that it's the same distance on both sides. So that puts right about there. Maybe we want it just a little bit further over. Okay. So we'll put this one over here. That looks pretty good. It's almost lined up. Maybe we would want it even a little bit further over. But now we can translate this little corner of their hip down this far, and to the right this far. So it would be down like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, oops, yeah, 13, maybe 12 and a half, and then over 1 and a half, something like that. So we could reflect it over this line, and then we'd have to figure out what this line is. What's the equation for this line? We haven't talked about vertical lines very much. We've talked about horizontal lines. We know that a horizontal line, like right here, would be y equals 5. So what do you suppose a vertical line would be? You might recall these words undefined, right? It has an undefined slope. It does not pass the vertical line test. It is not a function, but it still can be represented by an equation. It's just not a function. It's an equation that does not qualify as a function. So if a horizontal line is like y equals 5, y equals 10, y equals 12, y equals 13.7, what do you suppose a vertical line is? A vertical line is just going to be x equals that number. So this is like x equals 16. If we just scoot it over just a little bit, x equals 16. So that's our reflection line. We're going to reflect it over x equals 16. And then we said our translation was going to be down something like 12 and a half and over 1 and a half. So what did we do here? We did a reflection over x equals 16. And then we did a translation that was down 12.5 and right 1.5. So great work on those. Those were super hard. Feel free to play around with the frog, see if you could get the frog moved into different other places, maybe from different images to like from 2 to 4 or from 1 to 3. Feel free to play around with those as much as you want. And that brings us back to today's objective. I can list one or more rigid transformations that carry a figure to its image in 2 out of 2 problems.